What if the loneliest machine ever built just sent home a message that scientists cannot explain? What if the answer changes what we think we know about the edge of everything? Before we go any further, hit like on this video, subscribe if you're new, and share it. Share it with one person who still looks up at the night sky and wonders what's out there. This story deserves more eyes than it's getting, somewhere out past the orbit of every planet, past the edge of everything astronomers can point a telescope at and call home. There is an object. There's a small metal object drifting through the dark. It's not much bigger than a car. It doesn't have a crew. It doesn't have a screen, a modern chip, or anything you'd recognize. It was built in the 1970s, using parts that would look ancient inside a computer museum today. And yet, right now in 2026, this object is doing something no human invention has ever done. It is sitting in a place no telescope on Earth has ever truly seen from the inside. And it is sending back signals that are making some of the most respected scientists admit things. They admit they don't fully understand what they're looking at. This is Voyager 1. You've probably heard the name before. Maybe you remember it from a science class or a documentary, or maybe a meme about a golden record floating through space, but you don't know the status. There's a good chance you don't know what it's doing right now, in this exact year, and why the data coming back from it has physicists reaching for words like unexpected and unaccounted. In some papers, it is described as almost uncomfortably close to saying we don't know. Here is the short version of why this matters. Voyager 1 was never supposed to leave. It was never supposed to leave the solar system. It wasn't built for that specific goal. It wasn't designed with that goal in mind. Its entire mission was supposed to end decades ago, quietly, after a short tour past a couple of planets. Instead, it kept going into the dark. It crossed a boundary that separates our solar system from the rest of the galaxy entirely. It became the only human-made object to ever do so while still working and still listening. It is still talking to us. And what it found on the other side does not match. It does not match what our models predicted. Not close. And that mismatch is the whole reason. That mismatch is the reason we're talking about it today. So let's rewind for a moment, because to understand why this matters, you need to understand exactly how far it has traveled, and exactly how impossible its survival really is. In September of 1977, a rocket lifted off. It lifted off the coast of Florida, carrying two nearly identical spacecraft, Voyager 1 and Voyager 2. The plan behind them was ambitious for its time, but still modest compared to the actual results. Scientists at NASA had noticed something rare, an alignment of the outer planets every 175 years. Jupiter, Saturn, Uranus, and Neptune were lined up in a way that would let a spacecraft slingshot. It could use each planet's gravity like a slingshot, picking up speed and redirecting toward targets. It did this without needing extra fuel. It was an opportunity too good to pass up. Engineers built two probes to take advantage of it. The original mission plan was simple. Fly past Jupiter, fly past Saturn, take pictures, measure magnetic fields, radiation, and atmospheres, send the data home. After that, the spacecraft would drift off into the outer dark forever. Its job would be finished, its signal eventually fading into silence. Nobody expected it to matter. Nobody expected it to matter much after 1981. Nobody expected the name Voyager to still resonate to people who weren't even born yet. But Voyager 1 didn't stop where they expected. It flew past Jupiter in 1979, capturing the first truly detailed images of the giant planet. It saw swirling storms and strange, volatile moons. It reached Saturn in 1980 with detail, revealing details about its rings and its icy moon Titan that scientists had never seen before. And then, instead of powering down, it kept moving outward, faster than any spacecraft before it. It used the last of its planetary flybys to build up speed that would carry it beyond anything humanity had ever built or launched. By the late 1980s, it was distant. Voyager 1 had already become the most distant human-made object ever sent into space. And it was still working, still sending back a faint signal every day to Earth, carrying numbers and measurements across a gap of space that grew wider with every passing year. Engineers who built it in the 1970s had mostly retired. Some had passed away already, and their machine was still out there, still doing its job, decade after decade in silence. It worked on hardware that would be considered a toy by today's standards. Then, in 2012, something happened that changed the entire meaning of the mission. It crossed over. Voyager to Voyager 1 crossed what scientists call the heliopause. If that word is new, here's a picture. Our sun isn't just a source of light and heat. It constantly blows out charged particles. This is called the solar wind, and this wind pushes outward in every direction constantly. It forms an enormous bubble around our entire solar system. Every planet and moon is inside. Every spacecraft we've ever launched, everything alive on Earth, all of it sits inside that bubble. The heliopause is the outer edge of that bubble, the exact place where solar pressure ends. The pressure of the space between stars takes over. Cross that line and you're out. You're no longer inside our solar system's protective shell. You're in the space between stars, real interstellar space. In 2012, Voyager 1 crossed that line and kept transmitting its data. For the first time in history, a human-made machine had physically left our solar system. It was still alive, still talking to us from the other side. Think about how strange that actually is. We had sent spacecraft to other planets before. We had sent telescopes into orbit around Earth, but nothing before Voyager 1 had stepped out. It had physically stepped outside our own cosmic neighborhood and reported back on what it found. Every previous idea we had about interstellar space came from indirect evidence and far observations. Light passing through it, radio waves bouncing off it, mathematical models built from a distance. Voyager 1 was the first instrument to actually sit inside that environment and describe it. It was like the difference between reading about a country and finally walking through its streets. And what it found didn't match the textbook. For decades before reaching the heliopause we predicted, physicists had built detailed models predicting what interstellar space should be like. Not guesses. They were the product of some of the best theoretical work in modern physics history, built on decades of observation and calculation. Almost all of them agreed on one basic idea. Interstellar space should be calm, quiet, a thin, cold, mostly empty stretch of plasma, where particles drift slowly and not much changes from one region to the next region. Picture a vast silent room compared to the noisy, active environment inside our solar system. Voyager 1 walked into that supposedly silent room and found it wasn't silent at all. Starting around 2017, an instrument on board called the plasma wave detector began picking up things. It picked up a faint, steady hum in the interstellar plasma, a kind of background vibration. According to every model built before this discovery, it simply shouldn't exist in that way. This wasn't a single burst of noise that could be explained as a glitch or event. It was continuous. Year after year, the same signal kept showing up across millions of miles. To put that in perspective, the distance between Earth and the Sun is 93 million miles. This signal has been detected across a distance nearly 10 times greater than that gap, out in a region that was supposed to be almost empty. Researchers published findings. They published their findings in respected scientific journals and didn't downplay how strange this was. Their conclusion, in plain language, was that interstellar space is not the quiet void described. It has structure. It has motion. It behaves in ways that are more complicated, more layered, and honestly more alive than anyone expected before we had a working instrument, actually sitting inside it. Now here is where this stops being about faraway space and starts becoming a story about us. The same bubble that Voyager 1 crossed matters. The one separating our solar system from this turbulent outside environment isn't just a line. It acts like a shield. It helps deflect dangerous high-energy particles from exploding stars, keeping the most extreme forms of cosmic radiation from reaching the inner solar system entirely, including Earth at full strength. Scientists have generally assumed that SHIELD behaves predictably, based on models built before we had any direct measurements from the other side. But wait. But if the environment pressing against that shield from outside is more turbulent and energetic, and less predictable than we thought, then some of our assumptions need looking at again about how well that shield protects us over long stretches of time. We must reevaluate. Nobody is saying we're in immediate danger. That's not the point of this story today. The point is that a machine built in the 1970s used simple technology for results. Technology far simpler than what's in your phone just forced modern physicists to admit errors, that a piece of the model protecting life on Earth might need updating. That's big. That alone is worth sitting with for a moment. And now let's slow down here and get personal about the machine itself, because what happened in 2023 was dramatic. It might be one of the most quietly dramatic engineering stories most people never heard. For 5 straight months in 2023, Voyager 1 kept sending signals back to Earth constantly. But nobody at NASA could understand what those signals actually said. It was gibberish. The data was scrambled, garbled, unreadable, like a letter written in a language nobody saw. The spacecraft was clearly still alive. It was still trying to talk to us, clearly. But whatever it was saying had turned into static nonsense the moment it reached mission control. For a team that had been running this mission since before its own engineers were born. This was unlike anything they had dealt with. Eventually, they traced the problem to memory. They found a single memory chip inside the computer, a tiny component that had degraded. It degraded after nearly 5 decades of nonstop exposure to cosmic radiation in space. One small chip, roughly the size of a fingertip, had developed a fault scrambling data. It scrambled the part of the software responsible for formatting and sending scientific data back. Back to Earth. There was no warning light, no alarm. It had simply worn out. After 46 years of continuous operation in one of the harshest environments ever endured. Under normal circumstances, fixing a broken part means going to where it is and swapping. That wasn't an option here. The chip in question was 15 billion miles away from us. further than any human vehicle has ever traveled, with no possibility of a repair mission, not in any useful time frame. The only tool available was radio communication via waves. Even radio waves, traveling at the fastest speed in the universe, took 22 hours to arrive. Another 22 hours for any reply to come back. So imagine that repair process carefully. Imagine what that looked like from inside the control room. Engineers would look at data, they would form a guess about what might be wrong and write instructions to test. They'd send it, then wait almost a full day. When a response finally arrived, they studied. They realized it revealed something slightly different than expected, then they adjusted their theory. They would write new instructions and send them again. Every single round took 2 days, 2 full days to complete, and there was no guarantee any of it would work. One wrong command sent across that distance risked permanently damaging or ending the mission. There was no way to undo it. For months, the team worked through this puzzle. They worked patiently, carefully, under a kind of pressure most engineers never experience today. And eventually, they figured it out. The corrupted section of memory couldn't be fixed directly, but it could be relocated. The affected code was split into smaller pieces and moved. It was moved to different working sections of the spacecraft's remaining memory for storage. Each piece was rewritten so it would still function correctly from its new location. Then, it was carefully reconnected to work as a whole again. It was precision surgery. It was surgery performed remotely, through a nearly 2-day communication delay on an old patient. A patient built in the era of disco music and rotary phones. In 2024, it returned. In the middle of 2024, Voyager 1 came back online. Clean data, readable signals, recovery. And almost immediately, it went back to sending more of that same strange plasma information. Information from interstellar space, more evidence of the turbulence nobody had expected to find. A machine that should have died decades earlier had just survived its closest call yet. And it came back with more secrets to share. If this story has your attention, it's your. That's exactly the reaction we're going for. Smash that like button before you keep going. It genuinely helps this video reach more people who'd find this just as fascinating. Let's keep moving, because the strangest part of this whole story is still ahead. Let's go back to 2012, when Voyager 1 first crossed the heliopause in the dark, because the details of what actually happened there are stranger than most people realize. And they're the real reason physicists have had to rethink parts of their models. For years before that crossing, scientists predicted what the boundary would feel like to cross. The general expectation was a slow, gentle transition, the solar wind gradually thinning out. On one side, the interstellar medium gradually becoming detectable on the other, blending smoothly, blending together the way a river slowly widens into the sea. A smooth handoff. Between two environments, that is not what Voyager 1 recorded. At the boundary, something else. At the boundary, particles weren't calmly thinning out. They were slamming into each other. They slammed at extraordinary speeds, generating conditions reaching tens of thousands of degrees. Not inside a star, but right at the outer edge of our own solar system. In a region that was supposed to be cold and mostly empty. Scientists describe this. Some scientists have described this zone as an intensely energetic barrier, a genuine wall, a wall of charged particles marking the true edge of everything we call home. Not a metaphor, a real physical, violently active region that nobody's model prepared us for. Then there's the magnetic field discovery, which might be even harder to wrap your head around. For decades, one of the core predictions was that the magnetic field environment would change. It would change dramatically and cleanly. Inside the bubble, our sun's magnetic field dominates. Outside it, the galaxy's own separate magnetic field takes over. Two completely different systems, cleanly divided at the boundary, like stepping from one country into another with a border. What Voyager 1 actually found was far messier and far more interesting than that. The magnetic fields on both sides of the boundary weren't cleanly separated at all. They were, in ways existing theory hadn't predicted, connected. The sun's magnetic field lines, carried outward by the solar wind and compressed to the edge, were interacting outside. They interacted with the galaxy's magnetic field through a process of linking and energy exchange. In simple terms, our solar system and the galaxy aren't magnetically isolated from each other. They're linked, exchanging energy at the boundary in ways nobody had built into models. Not before Voyager 1 actually measured it directly. This isn't a minor physics footnote. If the relationship between our solar system and space is more connected and dynamic, and more energetic than we thought, then some of our long-term assumptions need revision. Assumptions about how the sun's protective bubble behaves over enormous stretches of time, not because anyone got the basic idea wrong, but because nobody had the chance to check the details directly until one small aging spacecraft finally got there and told truth. Now, let's bring the story fully into the present, because 2026 is important. 2026 is turning into one of the most important years in its nearly 50-year history, and most people have no idea it's happening. Earlier this year, NASA made a decision. NASA made a decision nobody working on this mission wanted to make. They switched off. One of Voyager 1's scientific instruments was switched off after decades of continuous work, not because it broke. It was still working perfectly fine. It was for power. It was turned off because Voyager 1 is running out of power and there wasn't enough. There wasn't enough left to keep every instrument running. It gets its electricity simply. It gets electricity from devices that convert heat from decaying plutonium into usable power. At launch, this system produced around 470 watts, enough for a couple of hairdryers. Today, nearly 50 years later, it produces a small fraction of that original amount, and it keeps losing a little more every single year. At some point in 2030, at some point in the early 2030s, the output will fall below the minimum needed. It won't be enough to run any instrument at all, and Voyager 1 will go silent. The team managing the mission has known this day was coming for a long time. Years ago, they worked out a careful plan for which instruments to shut down next, trying to squeeze as much scientific value as possible out of a shrinking power supply. Of the 10 scientific instruments carried at launch, most have already been turned off. Every decision about what to shut down next is one of the hardest calls made. Once an instrument goes dark, there's no turning it back on, ever. It is final. But here is a detail that hasn't gotten nearly enough attention. Engineers haven't given up. They haven't given up on buying more time. Right now, teams at the laboratory are experimenting. They are experimenting with a way to redistribute power across the remaining systems on board, hoping to squeeze out extra electrical capacity from components not currently at full efficiency. It's a delicate, risky idea because even small changes to power flow could be fatal. With no way to manually intervene if something goes wrong, it could produce results, unpredictable results. So the team is testing this approach first on the twin Voyager 2. Voyager 2 has a little more spare power and sits slightly closer to Earth, making any mistake a bit less catastrophic. If those tests succeed, the technique follows. The same technique may be attempted on Voyager 1 itself, potentially bringing an instrument back, potentially allowing that recently shut down instrument to come back online. No promises made, but they're still trying. Because with this particular spacecraft, betting against it has never paid. And now here's the moment on the calendar that's already locked in and certain. Regardless of whether anyone is paying attention. Later this year, it will cross a distance. Voyager 1 will cross a distance from Earth so vast that radio signals take time. Traveling at the speed of light, signals will take a full 24 hours to reach. Send a message on a Monday, and you won't know if it arrived until Tuesday. You won't hear anything back until Wednesday. 2 entire days for one simple exchange. No human-made object has ever been that far away. Not once in our history. And Voyager 1 will cross that threshold while it's still alive and transmitting back. Still sending back fragments of information about a universe that keeps refusing expectations. If you've made it this far, you clearly care about this story. Drop a word. Drop a single word in the comments, whatever word describes how this makes you feel. Curious, uneasy, amazed, whatever comes to mind. I read every one of them. It genuinely helps decide what we dig into next. Let's talk about the end. What happens after Voyager 1 finally goes quiet? The ending isn't really an ending. Every hour, it travels roughly another 38,000 miles deeper into interstellar space forever. As its power keeps shrinking, the communication delay keeps growing further every passing month. At some point in the early 2030s, the very last usable signal will come home. It will arrive and be recorded by a team of engineers who know the significance, and then there will be nothing after it. But Voyager 1 itself doesn't stop. There's nothing out there to stop it. No air resistance, no atmosphere, no nearby gravity. It will simply keep moving, silently, in a straight line, at 38,000 miles per hour, into a darkness that has no meaningful end on any human timescale. And bolted there. Bolted to its frame is something that will outlast everything else we've ever built. A gold-plated copper disc carrying greetings recorded in dozens of human languages and sounds. The sound of rain falling through a forest, ocean waves, and human laughter too, along with nearly 2 hours of music chosen from cultures across human history. There are diagrams explaining basic principles of our science and mathematics and maps. A map built from the positions of pulsars, designed to show whoever might find it. Location. It shows exactly where in the galaxy our small planet sits, a message in bottle. The scientist who designed that record described it as a message thrown into the ocean. That description holds up perfectly today. Whoever or whatever eventually encounters it will know that record will tell them something simple and true. There was a species here. They were curious. They reached outward. They built something from metal and electricity. They sent it beyond everything they had ever known, carrying the sound of their laughter. And their own rain. That record will still be drifting long after the sun swells, long after it consumes the orbit Earth currently occupies. It will still be traveling, long after every human city, every archive, every carved name in stone is gone, worn away by time and geology. It is possibly the most permanent object created, and it's riding on a spacecraft that runs on less power than a kitchen appliance. Now, let's come back to the science, because one detail deserves the center spot. That strange persistent plasma signal detected since 2017 isn't just a curiosity for us. It represents the first continuous, real-time measurement of interstellar plasma density ever managed. Before this, scientists could only get scattered, occasional snapshots of conditions in space, usually triggered by rare events like massive eruptions from the sun that rippled out. Useful information, but scattered, like trying to understand weather using one thermometer. What this persistent signal offers instead is something closer to a continuous feed, a running picture of interstellar plasma changing and shifting as the spacecraft moves through. And that picture tells us something simple but profoundly deep about the void. The space between stars is not empty, static background scenery at all. It has texture. It has its own version of weather and structures of particles, stretching for millions of miles, interacting with the edge of our solar system daily. There is still a real, open question at the heart of all this today. The signal could be explained in two different ways, and researchers can't say which. One fits comfortably within existing physics, describing a natural vibration in plasma. The other points toward a different mechanism entirely, requiring revisions to our models. Settling that would require more data directly from Voyager 1 while it's alive, which produces less every year as instruments get switched off to save power, or an entirely new mission built specifically to study interstellar space with modern tools. No such mission currently exists. None is currently funded or planned for now. Even if approved today, it wouldn't reach that boundary for another 2 decades, which means when Voyager 1 finally goes quiet, the question will remain sitting there. The picture it started drawing will simply stop updating. The window will close. And it will likely stay closed for decades. Here's what's worth sitting with. Right now, the only living scientific instrument in interstellar space is 50 years old. It runs on technology that predates personal computers, powered by less than a light. And it's quietly rewriting parts of what physicists thought they understood about the universe. We've built things since then that are larger, more powerful, and far more expensive. None have told us what this machine is telling us right now, because none had the one thing Voyager 1 had, the sheer persistence to arrive. Some questions about the universe can only be answered from the inside, not telescopes, only from a machine that physically crossed the boundary and kept transmitting back home. Right now, we have exactly one such machine. It's old, it's fading, it's running on almost nothing. And as long as it whispers across that distance, the least we can do is listen, because when it goes quiet, questions go too, maybe for an entire generation. If this story stayed with you, subscribe now. Turn on notifications, because there's a lot more of this waiting to be told. Tell me in the comments which part surprised you most. Share this story today. Some stories deserve to travel almost as far as the machine they're about.